I think they're recording this now.
Yeah.
Yes.
Okay, great. So Benny is also right.
Benny is also here, but Benny will join probably just in time. And I understand we had I think got a registration list, and if I'm not there, Benny is just joining in.
Okay.
I think Manu is there.
Okay.
Hi, Mirek.
Hi, Manu. Good to see you.
Nice seeing you.
By the way, Koshi is doing a fantastic job as an associate editor for Automation Construction.
Benny, yeah, I know. Benny keeps us updated.
Okay, it keeps you very busy.
Yeah. So Benny just joined, Merrick. I don't know whether you can see him.
Smiling. Hi.
Hi, so I think some of the attendees have already started joining, so maybe we'll wait for 5 minutes and then start.
Okay. So I think we are ready to start on time then. So whenever you
We
are,
have another few minutes, right?
yeah, 5 minutes are still there.
Yeah.
So we can start.
So
sharp at
just
6:30.
to give a heads up to Merrick, I think there were about 800 registrations on the
Wow.
on the portal. Now we have to see how many joined from that, but that was the number of registrations we got. I
Okay.
think our global engagement office sends kind of reaches out to many groups, and yeah, so that's a good number. We are hoping we'll push it to 1,000.
All right. Wow. This may be the largest venue I have ever moderated.
No. This can be larger. We are only starting out. So I mean that's a number of registrations. We hope it'll all the turnout will be as much.
Okay.
I think there's also a live stream in YouTube, so I guess some people may be catching it on YouTube.
This number, I'm sure it can.
No, Manu, I think they're not going to live stream. They're going to record and show. That's
Okay.
what.
Yeah.
That's what
The
goes.
YouTube live stream is this not.
Yeah.
yet.
It will be recorded and put on YouTube.
Sure. Okay.
Okay. Good. So what time is it in Chennai right now? It must be
6:27 in the evening.
6:27 in the evening. Okay, so it's still a reasonable hour.
Yeah. So it was a good time match. I hope it's not too early for you.
No, it's 9:00 a.m., so it's fine.
Yeah. But we really appreciate you finding time for it, and
Very much, Merrick. Thanks a lot.
Yeah, my honor and pleasure. In fact, now as a person with IIT affiliation, it's my duty to.
Yes. It will be formalized very soon. I have to update you on that.
Thank you.
Ashwin has just joined us.
Hi,
Okay.
everyone.
Hello, hi Ashwin.
Hi, Mirek. How are you?
Fine. Good to see you.
Good to see you too.
So not everyone is on campus, right? People are in different locations.
Yeah, I just came home.
Okay.
No, it's Dean. Yeah, this is also.
No, that's good. No, it's not Manu. Logged in. Manu is 3 times.
Manu, we see your name on 3 logins.
Somehow, I don't know. Ravindra is also showing up with my name. And Tamali also has my name.
Tamali is also showing up with your name. So
Well, there's one
Radhakrishna
more.
is a bit concerned.
There's one more with my name. Okay. So 4 actually.
That's Shivakumar. This is Shiva.
There
is some issue there.
so I think
No, I think they would have
That's
signed in with the link
invitation.
that I forwarded instead of the
Yeah.
link that they got directly.
the invitation that you
Okay.
forwarded.
Now it was good to have changed.
Yeah, I think you can rename yourself if you go and click. It gives you an option to rename.
The message.
So yeah, Dhanya, I think we can start. We are about 125 people already.
Yes. A very good evening to everyone that has joined us today. It's my pleasure to welcome you to the second webinar of the IRIS 2.0 webinar series. Before we begin today's session, I request everyone to please drop your questions only in the Q&A box, and please do not spam the chat box. We will not be taking any questions from the chat box. So today's session will showcase the Center of Excellence in Technologies for Low Carbon and Lean Construction. The center aims to develop innovative, low carbon, lean construction technologies for minimizing waste throughout the construction value chain and lead solution implementation across organizational and policy levels. It's my absolute pleasure to welcome today Professor Manu Santanam, the principal investigator of the project, and the entire TLC2 team, along with Professor Mirek, our moderator for the session today. Welcome, everyone. To give us a more in-depth introduction to our speakers and moderator, I would now like to welcome Dr. Nikhil Bugalia. Dr. Nikhil is currently working as an assistant professor in the construction management group at IIT Madras. His primary research areas focus on understanding the interactions between technical, human, and organizational issues in safety management for the construction sector. He serves as the secretary for the Special Interest Group on High-Speed Railway at the World Conference on Transport Research Society. Over to you, Dr. Nikhil.
Thank you, Dhanya. Thank you for setting this up, and welcome everyone to this webinar on our Center of Excellence on the Technologies for Low Carbon and Lean Construction. I'll start with a very brief agenda. So we will first have a 10 to 15 minutes PPT delivered by Professor Radhakrishna Pillai and Professor Koshi, which will be giving you an overview of TLC2 and the current progress. And this will be followed by a moderated panel discussion, which will be moderated by Professor Mirek. At the same time, the Q&A chat. Q&A is always open. So all of our colleagues will be answering some of the queries by typing the answer straight away. But towards the end of the session, we will also have opportunity for taking some of these Q&A and answering them live, right? So please keep on sending them. And I request all my colleagues to also keep answering some of the relevant questions over the Q&A box, right? So let me start with a very brief introduction of Professor Mirek. He's currently a professor of civil engineering and management and leader of the E-Construction Group in the Center of Excellence in Project Management at the University of Maryland. He was formerly a professor and an associate provost at the Purdue University in USA. His research interests are in intelligent construction, information and communication technologies for construction project management, and in construction automation and robotics areas. Professor Mirek has won several accolades and National Science Foundation's Presidential Young Investigator Award, American Society of Civil Engineers Walter L. Huber Research Prize, and International Association of Automation and Robotics in Construction's R. Tucker Hasegawa prizes are among the few of the accolades, just to list a few. He was a past president of International Association of Automation and Robotics in Construction, and he's an author or co-author of more than 400 papers and several books in this domain. Since 1994, Professor Mirek has also been serving continuously as editor-in-chief of the most prestigious journal in this topic called Automation in Construction, an international research journal published by Elsevier. And since 2018, he's also a co-editor-in-chief of the Frontiers of Engineering and Management, which is published by Spinjoy. So we thank you, Professor Mirek, for joining at this time of the hour. Let me also give you a brief introduction to some of the other speakers. So I'll start with Professor Koshi Verghese, who is a professor at the Department of Civil Engineering at IIT Madras. And his research interests are also primarily in modeling and automating engineering processes using appropriate computational methods and tools. And he has been involved in developing a unique postgraduate program in partnership with L&T. And this program has been successful running at IIT Madras for the past 26 years. And it's recognized as a model for university industry in the interaction in our country. In addition to this, he has performed several key administrative responsibilities at IITM, and he has mentored several startups within the areas of his research at construction and automation, along working at Institute's Research Park. Along with him, joining today is Professor Radhakrishna Pillai, who is also a professor at the Civil Engineering Department in Building Technology and Construction Management Group. Professor Pillai is particularly focused on developing corrosion test methods, databases, and tools for practicing engineers to promote service life-based design of concrete structure. And he has co-authored more than 60 journal papers and filed 3 patents, and some of them have already been granted. In 2019, he was bestowed with the Award of Excellence in Corrosion Science and Technology Award by the NAC International Gateway India section, among many other awards that he has received. Finally, the session will also be concluded by Professor Manu Santhanam, who is the principal investigator for this particular Center of Excellence. Professor Manu Santhanam is currently also serving as a Dean of the Industrial Consultancy and Sponsored Research at IIT Madras. His research domains cover cement chemistry, multi-scale characterization of concrete, including non-destructive testing, assessment and deterioration mechanism in concrete and masonry structures, 3D printing of concrete structures, durability, and supplementary cementitious materials. He has co-authored more than 70 journal publications, and he is also a member of editorial board in leading international journals on construction materials, such as Advances in Cement Research, ASC Journal of Materials, among others. So please, thank you so much for all being here. And with this, I would hand over to my colleagues, Professor Radhakrishna, to first give an overview of the Institute Center.
Yeah, thank you, Professor Nikhil, for giving that introduction. So I'm going to talk about the type of work which we are doing in this TLC2 center, and also a brief on some of the materials related work which we are doing. So we have this grand challenge of zero carbon and zero waste from construction. How do we achieve that? If you look at this carbon footprint of the construction sector, we can say there is divided into 2, embodied carbon and operational carbon, of which the embodied carbon is about 74%, very high. So our focus is mainly on that. How can we reduce that by looking at both material science, the type of materials which we use, and also the type of construction processes which we have. So in a short, our center's approach is to bridge fundamental material science to applied concrete technology, to applied to accelerated construction, and finally even to the policy and how various policies can be made to actually implement other scientific understandings which we have. And so eventually we will lead towards a sustainable construction ecosystem. So that's our approach of the center. And our research focus is mainly looking at the how do we minimize and reuse material waste, and how do we recycle and reuse the material waste, and how do we minimize the construction process waste. So if we can do these two, then we can really achieve the sustainable construction. So that's the whole idea. So if you look at the circular economy for construction, which our group is focusing on, I would say we have a group of faculty looking at material science and how various waste materials can be made suitable for use in concrete, and how we can tailor such concrete mixes for various properties, both at the early stage of the concrete and at the later stage, which is essentially durability, sustainability, etc. And also how we can modify our construction processes so that we can get really good accelerated and safe construction practices without compromising on other aspects. And eventually, we are also looking at how we can reduce the, or minimize the, repair or such, reconstruction activities by building durable repair practices, and also looking at how can we control the segregation or, the policies for practices to manage the waste from various agro waste, various sectors, including agro, steel, power plant, or various industries. And also we are looking, very focused on how to recycle and process the construction and demolition waste. That's one of the major focus of the center. So this is the circular economy aspects which we are really focusing on. And we have collaborators from all over the world. You can see there's a lot of, I'm not going to read this, but we have pretty much collaborators from all the continents. And we have also graduated about 50 students who are now, pursuing their PhD or postdoc or working as a faculty members in various institutes in India and abroad. And we also work closely with the industry and then some startups assisted, to form startups. So these are the companies which are closely working with us in the TLC2 aspects. And to get into this little bit about what we are looking at the, material science, or how we are looking at how we can use waste from agro, power, and steel industries. One example is that we looked at, getting a map of available waste from the paper industries in India. You can see the India map on the left side. And then we also looked at how much, how much of such material is available. Is it really, good enough to promote it as a material for construction? And we're also looking at how we can use such waste materials, or how we can process, and then looking at the chemical aspects of such waste materials, and then how we can design the concrete systems to achieve target strength and other properties. Similarly, we are also looking at the performance of waste materials from rice, sugar, power, steel industries, etc., to be able to use in concrete and make durable constructions. Other area which we are focusing is the way, how to utilize waste from construction and demolition industry. One of the project which we are looking at, or where we worked with one of the major metro in India, is to see how we can utilize this waste, huge amount of waste from the cutting of piles from major infrastructure projects. So such concrete is very weak in strength, but at the same time, they are really good concrete, or rather uncontaminated concrete. So that aggregate from such concrete can be really nicely used. And in this demonstration project, we worked with Chennai Metro, and then we demonstrated how we can crush or process this waste, and how can we make good quality concrete. And when we look at, we even looked at not only the strength properties, but also the durability properties of the concretes made with such concretes. And we have also sent policy notes on how to use various waste material for use in concrete. Other project which we took up is, we have been working on durability of various concrete systems for several years, even well before the TLC2 center came up. But this was a very good opportunity for us to take this research output to the field and try to implement them. So in this project, we worked with one of the government agency in Kerala Highway Research Institute, where they were building a major bridge on the coast. And this target service life of the bridge was about 100 years. And they were actually using M40 mixed designs, as you see, with the OPC, type concrete. And what we suggested them is to go for slag or any other SCMs possible, but we eventually decided to go for slag-based concrete because it's a coastal region. So what we were able to do is, if you look at the photograph at the bottom, the mid-span, by the time we were able to influence, it was, the project was already up to this stage, but luckily we were able to use the slag concrete in the mid-span. And to really implement it, first we had to, convince them that this concrete is actually useful. So we cast specimens on site, tested, concrete specimens collected from the, actual structure. And we found that the durability of such concretes can be very, very high as compared to the OPC concrete. And we also looked at the service life estimates, where we found that by using the slag concrete, we were able to find that, the service life can be about 4 times more than the OPC based concrete. So this was very promising, and then they were very happy. And now, we know that they are actually implementing this type of concrete in other bridge projects as well. But to actually implement it on site and to be able to, give a good quality control, etc., we have to specify some properties, for which we have also developed some nomograms where we look at the properties of the binders, the structural design aspects, and then we say, okay, if you use this, then you have to, go with this type of concrete, which will have a durability parameter, which is, I'm calling it MXDY. M stands for the mechanical parameters and the DY stands for the durability parameters. So if you're talking about a target life of 100 years or so, we have to bring in a durability parameter to specify the concrete. So that's the whole idea. And we also looked at how these slag concrete mixes, which we have, how sustainable they are. And then we found that, as you see in this graph, where the bottom left corner, the more the mix comes to the bottom left corner, it indicates it's more sustainable. And we also looked at carbon footprint, which we were able to save through this, changing the mix design from OPC concrete to slag-based concrete. About 36% carbon footprint savings is possible if we were actually doing the entire bridge with slag concrete. But for this particular bridge, we were able to save about 12% because only one span was, possible to change the mix design. But for future, we expect, more and more such projects where SCMs and MXDY concrete concepts, if we can implement, we can really save, we can make durable construction and at the same time save a lot of carbon footprint. I think now I will request Professor Koshi Varghese to talk about the process waste and how we are handling that.
Yeah, thanks, Radha. Hello, everyone. So the topic which I'm going to cover today is on the lean maturity model. So to give a bit of background, lean construction or lean project delivery has been something which the Indian industry has been trying to learn and adopt for the last about 10 to 12 years. And we have an organization called ILC, Institution for Lean Construction Excellence, which has several large construction groups in the country, and they have always been trying to take the effort to be able to gain from lean and implementing lean principles. So there is a lot of introduction I can do on lean, but I think to keep things within the time here and to be able to accelerate. So one thing we have found over the last 10 years is that there is as you can see on the slide on the cartoon here, there has been many interpretations for lean. And this is not just in the Indian context, but also in the global context. People look at lean from different perspectives. It's like the blind man and the elephant, and they tend to look at their own interpretation of lean and start kind of working with that. So one thing when you have seen, when we looked at from a holistic perspective, is that unless there is a roadmap from a little bit of a top-down approach on a roadmap and kind of a guidance on where you are on the roadmap, lean can be a very confusing journey to embark on. Now, before I go forward, I would also like to kind of add in terms of where lean fits in with our project. So TLC2 has a lean component. The lean is in terms of being able to bring projects in earlier. So if you're bringing projects in earlier with less overall waste, not just material waste, but also the other kind of waste in lean, we expect that there will be a better performance as well as less damage, less waste in terms of carbon emissions and everything else. So this is the main link we have from the lean perspective to what we talk about, not only sustainability, but also to the project delivery context. Now, to go on to the next slide. So when we look at the lean maturity model, we have, as I said, we needed a roadmap. Then we needed to also assess. So several organizations claim they are implementing lean, but we wanted to assess where they are. And they might say that we've been implementing lean for so many years, for so many this. They talk about the project benefits that they've adopted, but we wanted to kind of start because I guess in the initial years, there was a little bit of a distributed approach because people needed to explore where they are, but we needed also then people to start converging on the best practices. So we looked at the holistic approach to cover lean. So now we look at these dimensions which you see here. We are taking top management support, process, people partners, methods and tools and technologies. These are the key dimensions in which we feel that there should be progress for a holistic adoption of lean. Based on this, we looked at now what, so the concept of a lean maturity model is not new. There have been several maturity models that have been developed across the world, and I've listed a few of them here. Everything from the, you can see the MIT model is listed there. Highways England has a lean maturity model just for highway construction. So we assessed several of these models, and the limitation of these models are put. So one is there's no local context to the Indian context. So when you start trying to take some of the benchmarks from these models, there is no relationship to what is happening in India. So it just does not make sense. And there was inability to do relative comparison and a lot of other issues. So, you know, in terms of model being too theoretical, too many weighted indices in the model, you know, we were just not able to go forward with it. So we kind of decided that we needed to develop our own lean maturity model. So we call it the ILC lean maturity model, which is coming from the group at IIT Madras, along with collaboration with the industry. And basically, it should be Indian context with industry relevance. It should have the lean maturity based on our roadmap. There should be a general roadmap. It should not be too prescriptive, but it should be milestones that are familiar to the ILC organizations, taking best practices within the Indian context. And then also one thing that was important was to make to make visible progress. I mean, if you tell a company you're going to go to the next milestone only after 5 years, there is not too much buy-in. Whereas with every year, if they can see some progress made, there is also momentum developed based on this. And the last point, as you can see here, we wanted clear evidence based on documentation and observation. So when a team goes to assess the maturity, it should be evidence-based and not just on anything else. So this I have covered earlier. I'm not going to get into detail, but these were the dimensions on which we were basing the model. And we basically have, I'm going to kind of move to the next slide. We have now come up with a framework where there are these 4 levels. There's a L0, which says no awareness, because several companies also come to us and say they are doing lean, or several projects come to us and say they are doing lean just because there is some small aspect which they think it is, but we have an L0 for that. But we have L1 where there is a good management awareness and management support. So lean does start with the top, but a lot of times it doesn't percolate below the top management. Top management starts talking lean, but there is no percolation. So with L2, we have not only the project and the top awareness, but there is also the internal teams within the project are practicing lean. With L3, we have not only the project and the internal teams, but the external stakeholders are also going. And remember, all this is at the project level. Then there is a need to do an organizational level of lean, and that is at L4. So that means it's a very high maturity. Several of the projects of the organizations have adopted lean, and then the organization starting to come on the radar in the lean rating. So this is the scale we have. And the scale has been kind of calibrated today to the level at which Indian groups are adopting lean. I'm not getting into the details. Please don't try to read the slide. This is only to kind of show that we have different levels, and at each level we have a low, medium, or high. And there are, what you see in each of the cells are specific requirements to be at that level, and the evidences that the evaluation team will look for to be at that level. So with this, what we did was then we needed to actually start calibrating, see if this model works or not. So what you see is the photograph of a cement plant, which is under construction. So we actually, a team of us went here and tried. And so this group kind of was implementing a lean on the project. So we had several, we spent 2 days at site to look at all the dimensions. And while you can see, there's a full planning board there. There are teams of planning staff. There are teams of execution staff also there. And the impressive part of this group was that lean was actually practiced in several processes and at the site level. However, there was absolutely no documentation. So when you asked, people knew things, but there was no way they could kind of deep dive or go into more detail because there was no documentation. So we are actually positioning this group right now at an L1 medium, because having a documented strategy and process is a very important part of being able to move forward. Going to a second example, this is a metro construction. There are several metros going on site. So you can see a little bit of the tunnel as well as the station construction. There were several stations on the scope of this work. We visited all the stations. We visited the head office. We did meetings to assess what the kind of implementation was. So here you can see there's evidence of top management support. There were part-time lean champions. They had very good documentation of the process. There was very good awareness at the office. So any person you talk to in the office really had a good grasp of what they were doing. But when you went to the site and you started going down to the last planner or going into detail into how were teams actually affecting it, implementing on site, there was a breakdown in communication. So while the documentation was good, but it looked like they could do a little more to be able to get this thing going to site. And of course, this was a much more challenging, much bigger site with a lot more details. So the best position, we have not yet kind of placed them, but the best position they can go is at an L1 high. So we are going forward with this. Part of the TLC2 agenda is to be able to formalize this as a framework and be able to get other projects in India to be able to adopt these practices. And review and refinement, we need more pilot projects. And one of the feedbacks we always get is this has to be aligned with corporate benchmarking, whether it's with lean or with sustainability, and to bring in sustainability parameters also into this benchmarking so that an organization does not have to do different kinds of maturity assessment, but does a holistic kind of a single time assessment to be able to assess where they are. Okay, so now I think we're open for question and answers,
Yes.
right?
So thank you so much for everyone. There has been a lot of questions coming on Q&A session, and please keep them sending. We will keep them answering. But at this stage, I would like to invite Professor Mirik to start the moderated panel discussion, and we would be happy to take any questions also. Over to you, Professor Mirik.
Thank you very much. I see that there are a couple of questions that are already being answered in the Q&A window. I would like to see if there is anyone that wants to ask any additional question, but if not, I would like to bring up a concept that is just a concept right now. There is little literature or information about it. It initiated about 5 years ago at the European Union. And that's the concept of Industry 5.0, out of which grows the concept of Construction 5.0. It's essentially the effort to build upon the achievements to date of Industry 4.0 and Construction 4.0, and there's a lot of documentation and literature on that. To take advantage of information communication technologies and automation technologies and put them into service of sustainable industry, and in our case, sustainable construction. In other words, we are interested in environmental sustainability as well as economic, but with the emphasis on environmental sustainability, as well as resilience, particularly to climate change phenomena that are, of course, very well discussed, and they're always on the forefront of popular press and popular discourse around the world. But in addition to that, there is also a renewed interest in human well-being. In other words, there is a need to emphasize the well-being, the satisfaction of work of all the participants, all the stakeholders that participate in construction projects. I would like to ask the audience, anyone in the audience who would like to speak to that, as to how the ongoing efforts at IIT Madras in relation to recycling of construction materials, recycling the waste in particular that is being generated. That waste is really staggering. According to statistics in the United States, about 60% of all the volume of solid waste in municipal waste sites is actually construction related. It's either waste from new construction projects or retrofit projects or just outright demolition. So, and there is very little recycling. According to some estimates, at least on the East Coast of the United States, less than 10% of construction related waste is being recycled. The rest of it is actually ending up in filling up the volume, the space in municipal waste sites. What can the existing body of knowledge in construction engineering and management accomplish in changing that? How can we possibly address that issue within the framework of Construction 5.0? So let me direct that question first at our speakers, Professor Aslam and Professor Koshy. Would you like to start with some comments of your own on that?
Yeah, so thanks, Marek. Thanks for the question. I think in terms of looking at what you said, one is the use of technology, and from a human perspective, how do we bring in these factors into what we are doing? So I've just moved to this slide where we have, this shows the big picture of what the TLC2 group is doing. And also, I mean, and while we call it TLC2, there's also a lot more thinking that goes beyond what was just looking at from the TLC2 scope. So you can see two parts here. One is management and organization. I think if you look at the system thinking, management and organization, technology development and policy, which is on the upper 2/3 of the pyramid. So all of these kind of in a macro sense deal with what you're talking about. There's a lot of detail. For example, there is a technology, I think with Benny and group, there is a technology element to this, which is looking at roboticized separation, because a lot of times the waste gets dumped because there is no economical way of separating. So there is from a technology development point of view, there is use of 3D printing, and there's a lot between a materials group and a 3D printing group. There's a lot of work going on how do you actually not necessarily separate, but probably grind all of this and be able to make it as aggregate into 3D printed materials. So there is a lot going on the technology aspect in that. And also bringing in from the lean context. For example, one dimension I didn't get a chance to talk about is when we talk about lean implementation, we talk in 3 dimensions. We talk about people, process, and technology. So we need processes in place, we need people, and we need technology to be able to implement it. A lot of the time the technology exists, and it's not sometimes it is available to you. Changing the process is more difficult. Changing people is even more difficult. So these dimensions exist, and so definitely what the dimensions you're talking about are within the scope of what we can do. Some of the details we still have to work out. That is one. Just to close this, the last point I wanted to make on this, especially from the people and the well-being perspective. One of the questions we get asked on all the projects, for example, both projects which we visited or which I presented, the working time of the engineers and the workers or everyone, or other than the shift workers, is from about 8:30 a.m. to 10 p.m. Okay, which means they don't have a work-life balance. And even if the project is going in on schedule and going under cost, the challenge we put to them is, can you start working at 8 a.m. and finish your work at 5 or 6 p.m. and go back home and still get the project done? And what we are promising them is, if you try to adopt practices which are more lean aligned, things like that, you could do that, and with more collaborative work you can achieve it. rather than staying in the office till 10 p.m. each night. And because I mean, the family obviously suffers if the engineers are there all the time at work. Okay. So, yeah, rather, yeah.
No, I was saying like the planning, the need for planning the work.
Yeah. So those are more scientific aspects, but the people tend to, I mean, so here is a time where your personal time is, your professional time is eating fully into your personal time, because then that affects your quality of life. So I'm going to stop with that. Radha, you have anything to add? Nikhil?
I would like to add a little bit to the same on the technology side of it. One is even a lot of our colleagues are also working on finding sustainable ways to recycle, also going to the process of how this demolition debris is actually converted to aggregate, optimizing that process so that overall the properties of the outcome, the concrete that is made using these recycled aggregates, become better and better. So there is a technical element, there's a science element that goes there. But also coming from a larger perspective or more broader issues of management, city level kind of topics, we also look at something called reverse supply chain, right? How efficiently can we gather these construction and demolition debris? And you rightly mentioned in India, the official figure of recycling is less than 1%, not even 10%. So we face huge volumes, right? So that's also, we are also developing technology that can be deployed at a city level. For example, can you locate where the hotspots of these particular C&D waste debris are? Can you quickly quantify them so that there can be collection network of them can be optimized? We also have to be cognizant of the fact that in India, there is a lot of informal sector that exists in this. And in fact, the kind of waste that we get is very low value, as in these materials cannot be immediately resold, because by the time demolition happens, the informal sector kicks in and they already recover the highly precious materials. So some of the approaches that are available in other countries are not directly relevant to India. We also have to develop tech specific to our needs. There's also a trade-off between, if you demolish fast using mechanized processes, the recovery goes down. But if you use very manual process, the recovery of material can become efficient, but then there are a lot of safety related issues that comes to these workforce. So these are very interesting question, and that's where we are always thinking about a systems thinking approach to solve this issue. We have a group of people who all come up with different strengths, different disciplines, and together we try to look at the problems holistically so that our solutions are not just theoretical argument, but actually some sort of a practical approach within the Indian context as well. So if there are some other comments from my colleagues, please.
Yeah, thank you, Nikhil. You're bringing up indirectly a very interesting subject. By the way, the less than 10% figure that I mentioned from the East Coast in the US is primarily thanks to the fact that crushed concrete, unspent concrete, for example, from ready mix factories, concrete that was maybe delivered too late to construction sites to be poured into forms. That crushed concrete becomes a sub-base aggregate for sub-base for road building and maintenance projects on road building. There is very little of that, actually, as you mentioned, maybe less than 1% as far recycled materials being used for buildings. Some of it has to do with economics. I remember about 10 years ago in the US, there was a big jump in prices of certain commodities, such as copper, for example. And all of a sudden, copper wire recycling from demolition projects became very popular. Companies were interested in recycling copper. Why? Because it was so expensive. Some projects actually almost went bankrupt because the price of copper almost doubled in a matter of maybe 2-3 weeks. So on ongoing projects that take sometimes a couple of years to accomplish, that can be devastating for electrical contractors who have fixed price contracts. So some of it has to do with economics. Some of it has to do with equipment and processing. Some of the experiences that are compiled by other industries, for example, e-waste recycling. So recycling of what happens with almost 6 billion expired or old cell phones. That is a very interesting piece of information. How is that industry, the electronics industry, handling recycling waste? Some of the lessons learned in one industry can go across the different industries and be adopted and adapted to processes in completely different application domains. So that's one issue. I saw one of the questions was about 3D printing and how it can fulfill the promise of zero waste in construction. Well, zero waste will probably never happen, but 3D printing can actually go a long way, because rather than trimming materials, 3D printing allows the opportunity to use all the material that has been devoted to the construction process to be actually delivered on the project site and actually built into a structure. And of course, structural performance issues, how do we handle reinforcement challenges, what kind of reinforcement would be optimal for what kinds of projects, load-bearing capacities of these structures, technological issues, rheology of these materials are ongoing research topics, simply because we don't have enough information about rheology of 3D printed materials installed into construction projects, especially when it comes to load-bearing capacity or load-bearing portions of the structures. So no wonder about 80% of the total cost of research and development that goes into 3D printing and construction goes into materials engineering, not construction processes, but perfecting that concrete mix or other materials that would make them perfectly suitable for 3D printing. Lots of challenges remain. This is why it's such an exciting field of research and development at this point in time. All right, so I don't want to belabor that subject, but I just want to see what other questions we can possibly answer. There is one question about can you throw some light on the use of RFA in concrete? Because more research is there on RCA, but little less on RFA. Handling RFA is also quite different from RCA. Is anybody ready to speak to that issue?
Yeah, Mirek, I can take that up. This is Ravindra.
Okay, please.
This is a good question. Most of the research has focused on coarse aggregates, and we know that we generate a lot of fine aggregates during the crushing process and the beneficiation. We have done work where we have shown that the proper processing, that is in terms of crushing or some beneficiation, probably with some thermal treatment, can yield fine material that can replace sand. We have actually made concrete with all the aggregates, both the coarse and fine, coming from recycled material. So it can be done. One has to be careful because you get a lot of fine material, and the fine material means that you would need to add more water or more cement. So what we did is we fractioned out everything that was finer than 300 microns. And that solved a lot of the problems. Now, the next question is, what do we do with the fine material that is less than 300 microns? There are concretes such as self-compacting concrete or 3D printed concrete, which need a lot of fines. And we generally use fine sand and so on. So this could probably be used there. We are also looking at the possibility of using these fines in an activated way as an admixture, or maybe as material for making cement from. So it is certainly possible. We have done some work, and interested listeners can look up our recent papers on this.
Okay, excellent. I also want to bring up the issue that we actually started our presentations with Dr. Aslam. When we talk about carbon gas emissions from from either material production or material installation. So either embodied energy related to embodied energy aspect of carbon gas emissions or operational carbon gas emissions. I also want to point out the fact that just worrying about carbon gas emissions is an oversimplification of the problem. We have other issues to deal with. It's not just carbon gases. Carbon gases, by the way, are not the major contributor to greenhouse effect in the environment. Actually, there are some aspects such as naturally occurring phenomena such as water vapor emissions into the atmosphere. Water vapor is actually a greenhouse gas that has arguably maybe even a larger role in climate change than carbon gases. But in addition to carbon gases, other greenhouse gases also include NOx types of substances, gases, so nitrogen-based substances. So if we include if we go even further and not just embodied carbon from manufacturing and transportation and handling of construction materials, but also extraction of raw minerals that go into the production. For example, extraction of steel, of iron that results in the production of steel. Just the extraction mining processes also need to be taken into account. So if we are looking at the overall impact of construction on climate change, there is a lot more to handle than just carefully crafted or carefully selected processes. So there is a big role for big data and information technology in general to give us the kinds of tools that we need to address issues at the planning stages, then design, as well as construction, and then operation and maintenance, and ultimately recycling, demolition and recycling of built facilities or facilities in the built environment. Who wants to speak to the issue of design for sustainability of construction projects? How do we connect the design profession with the construction professionals to make things happen? And how do we educate the general public and the stakeholders in the construction processes to come up with solutions that are indeed sustainable and adaptable across all the phases of these projects? I know it's a challenging issue, but maybe with the collective wisdom of professoriate from IIT Madras, we can come up with some good ideas for future projects that can handle these challenges.
Yeah, I can maybe weigh in a little bit on that, Mirek, if that's okay.
Please do.
I think there are sort of several aspects to this when you look at design. I think there's architectural design, where you look at, for instance, passive strategies in terms of how you could orient buildings so that they have lesser energy loads and things like that. You also have structural design, where I think we've got to make efforts to see how sort of thin or light we can make our elements so that you consume as few resources as possible. So there's an engineering component, there's a material component there. And then, of course, when you look at design, you're also looking at designing heating, ventilation, air conditioning systems. So I think each of these aspects need to be optimized, not just individually, but collectively as well. And one way of doing that, I think, is to start setting benchmarks on what the embodied carbon of various kinds of buildings is. I mean, a 6-story university building versus a 3-story residential building and so on. And once you set benchmarks in terms of what the state of the art is today in terms of embodied carbon, then I think those need to go into specifications so that new buildings either meet or beat these benchmarks. Currently, I think an issue is that we don't measure as much as we should. And I think that is sort of a way in which we will continuously improve towards getting more sustainable buildings. I'm sure my colleagues may also be add on to what I've just said.
Really great.
Mirek, maybe I can add something from the construction materials and technology point of view.
Please do.
What you brought up on the limitations of just looking at embodied carbon is very much appreciated. I agree completely with you that just talking about embodied carbon is passé. We should talk about sustainability holistically, considering maybe the 17 SDGs and not just about embodied carbon. So you asked a very right question on how are we helping people in the field choose something that could be sustainable. So we started off looking at concrete. As everyone in the concrete field knows that there are infinite concrete mixes that could satisfy the requirement of a construction project, which is usually based on workability and compressive strength. So what we said is we'll try to come up with a framework. So we made a chart or a framework to have a chart made for any site, which would have indices based on 4 components. One would be the embodied energy, which also reflects the cost and the use of raw materials. The strength of the concrete, what could be the MX that is shown here. The other component would be the durability. We insist that durability is key to designing something sustainable with concrete construction. We cannot afford to have something that's not durable enough. And the 4th aspect would be the environmental, bringing in the carbon footprint. So we strongly believe, we agree completely with you that carbon footprint is not just the only way to look at sustainability, it's much broader. Now, as Ashwin said, we have to start looking at it from the design point of view. In a project that Ashwin and I are working together, we have found that in the contract stage itself, you have to know where your materials came from. That means when you put a specification out for bidding, the contractor has to be ready to tell you where all the materials came from, what are the sources, so that you can calculate the carbon footprint. Otherwise, you're stuck with having a database which need not be relevant at all. You could have a database made in Switzerland and try to fit into a concrete structure in Chennai, and it won't work at all. What we are also looking at is maybe a portal or a database. We are thinking of a materials passport, where people can put up the values that they obtain, not only for the mechanical properties, but durability and so on. So people can look up and then use this for an educated choice of sustainable materials and technologies in construction.
Right.
Thank you.
Yeah, thank you, Rohindra. This is very helpful and very informative. I think that this is an excellent background to the next question I want to ask is about the development of the proper decision support tools to guide us in the process of arriving at a most sustainable project possible. I remember more than 20 years ago, the first tool that was developed for that purpose was IOLCA. It was at Carnegie Mellon by 2 professors, Chris Hendrickson and Lester Lave. Chris is from the Civil Engineering Department, now Professor Emeritus, and Lester Lave was from the business school. And it was economic input-output tables for life cycle cost analysis. That tool is still, by the way, available for free on the internet. You can go to iolca.net and see how you can generate data and information about an impact of any material for any kind of application across all industries, including construction and manufacturing. But that was developed about 25 years ago. There is a need for better tools that take advantage of latest achievements of data science and deep learning approaches, as well as the latest achievements of artificial intelligence, perhaps working across all the databases that we have for for extraction of raw materials, processing these materials into products, taking advantage of open AI types of applications, whether it's ChatGPT or any other kinds of tools that are for generic purposes. How we can take it? How can we harness the power of the most advanced information technologies to make our construction projects more sustainable? Can anyone speak to that?
So yeah, so I'll start out with one dimension of it. I think we're going from the decision support or the tools. And I mean, as we know, there's a lot of tools out there, but all of them is driven by data. And so I think it is to be able to, how do we, so the organizational effort or the policies required to make sure that the data we use to calibrate these tools are relevant. So I think that, I mean, that is where I think we also have to start, because I think we have seen a lot of tools that are more conceptual, and then they do a prototype, and then they say, if you feed in the right data, it becomes okay. But it's where we have to start is with the data. And I think this is specifically, I think, as again, Ravindra said, in the Indian context, there is a lot of pipelines we have to develop to start gathering this data. And we see that these pipelines are starting to fall in place. And as policy in the government and policy among clients, for example, the project you talked about at the IIT Madras, we are saying that we want to be able to select the contractor based on your what you show as your material, the passport of what is there. So once these policies start in place, fall in place, I think the data will start becoming more available. And then we go to or in parallel, we have to go to the technologies which we are going to use. And I think there's a lot of technologies, I think, and this I would also like to bring in your earlier question on design. So in terms of the processes we use in being able to bring in the right materials and integrating this with design, we are going to go into a multi-criteria decision-making kind of issue. And again, we have a lot of models which can do that. But ultimately, how do you calibrate these models? How do you bring it back to your decision-making preferences, decision-making? So these are the tough questions we have always had to answer, whether it was 25 years ago or even now. And I think those questions will remain, but probably the optioneering which is available today with the computing power and the technology, the options we can generate to be able to see the what-if scenarios we can generate, to be able to do the simulations we can generate, will probably be able to give us a better way of coming to the right decision, the decision which we would want to kind of take it as a part of policy. So that, I mean, that is the way I would look at it. Nikhil,
Okay.
May I just add one point here?
Please.
Yeah.
So another direct application of AI-based tools or AI-based techniques that we can apply is to use large language models, which we call LLMs, in trying to assess the extent to which the policy that we draft or the contract that we draft is actually helping us in implementing sustainable practices or lean construction practices. Like if you look at the current literature, there are a lot of articles that classify whether a given text or given part of a contract, is it helping in promoting or is it causing disputes in terms of risks, or is it risky or not risky? Similar lines we can think of whether a particular clause can support collaborative construction practices, which is again supporting lean construction, or whether the clauses are drafted in a manner that really do not support implementing these practices in construction projects. So that is one interesting research area that's developing these days on use of large language models. Yeah.
Yes, thank you, Murali. This is very important as well. I see that we're quickly closing in on the hour. I would like to bring up some questions from the attendees online. One question has to do with standard creation and standard processing. That's important equally for India and for all the other major economies around the world. But it's also important for international standards organization. How do we see as a collective body of researchers and developers of technologies and practical applications in industry, how do we see the path to the creation of national and international standards that would advance the cause of sustainable construction. Can anyone speak to that? What can we possibly do to take this research, the results of research and development? How can we turn it into a suitable path, an efficient path for standards at national and international level?
I think we'll take that question in two parts. One is the kind of engineering and material standards. I think Radha will take that part, and then talking about management standards, I will handle that. Radha, do you want to take it?
Yeah. So we are working towards modifying the standards, but as usual in any part of the world, it's quite slow. But that's where the challenge is. I feel we need to attract more people towards the development of the standards. This is one thing which I see is that there is just because it is slow and there is a lot of hesitation even to participate in the committee meetings. People think that my time is going to be wasted, so I don't want to participate. So that's one challenge, I think. But of late, I would say there is a significant effort from the standards or BIS, Bureau of Indian Standards, to accelerate the inclusion of new technologies and research findings, etc., into the standards. So there is definitely a push, especially in the recent times. And we are also, as our team, we are also working on various standards on reinforced concrete design. Professor Manu is also part of that, and then precast concrete, how that is also another standard which is in the making right now. And also on the material side, different steel reinforcement, how can we, because there are some of the clauses in the codes are actually preventing from innovation, to use a new or better material just because there is a particular sentence in the standard or a clause in the standard. So such things we are trying to handle, but it is a slow process. But we need more people, especially I would say from the industry also, to come towards sitting in the committee meetings, etc. Not only academics, but also from the industry. I feel that contribution is very, very important.
Oh, excellent.
Manu, maybe you can.
I can just add from the management standards perspective. I think there is, in India, we definitely face a challenge. A lot of times, the science behind a management standard is not as well formed as the science behind an engineering standard. So within the engineering standards itself, like Radha said, there are formation issues, but once it's kind of published, there is a reasonable adherence and the results are followed. Now, the question is, how do you actually make the engineering standards usable and user-friendly? With management standards, what we find is, one is there is subjectivity in it. A lot of times it just gets on the table and nothing gets implemented. If I use a simple example for the BIM standard, there is an international BIM standard which talks about the BIM execution plan processes, everything. A lot of our BIM implementers don't even follow the standard. They just go about it their own way, and then they complain that this is not happening or that is not happening. So getting the culture of being able to be able to adhere to a standard when you have different practices, I think we are moving towards that as the standards are becoming more specific and more science-oriented. So I think that is one trend we see, but I think we need to go, but the culture of management standards is only coming into India now. I think slowly it has to take root, and I think as there is more client demand and more corporate demand for this, I think we are going to see more adherence to it. I'll stop with that. Ashwin, do you want to add anything to that?
No, I think you've covered most of the points, but I think there are. I think we've got to differentiate between standards and practices. I think standards will sort of be enshrined by some kind of a body that gives it some legal standing. But I think we also have to, keep sight of the fact that there are lots of practices in construction that can be influenced by the research that we're doing and putting out that can then change to make construction far more sustainable. And therefore, I think the answer is not only in the standards. Everything that we do will not necessarily become a standard. But I think a lot of what we're talking about will also hopefully may play a role in changing construction practices that will then lead to greater sustainability. So just wanted to add that point.
Yeah,
So I would-
Manu, we were wondering if you wanted to add anything.
No, I think I wanted to reiterate what Ashwin just said. Not all of the research that we do will end up in making standards which are relevant to the construction practices. We can, of course, provide a range of options for people to choose from in terms of the solutions for any given issue that they can face during construction with concrete in such circumstances. Yeah.
Okay, excellent. I think we have exhausted our time limit. If there are any other additional questions, maybe we can handle one last question for the panelists. I can see a lot of questions are coming from the attendees. We still have over 300 people logged in, but there's just no way we can answer all these questions.
So I
During
think
the
we
session.
will record them and try to answer them over time, Merrick. So, you know,
Also, we
if
have
there's
a-
any particular question you want us to take, we can take. Otherwise, we will continue. If you need to leave, you can, if you have any other commitment, you can always sign out whenever you want.
Okay, I can see
So I
that
think
there.
session, or I think Nikhil, over to you. What would you suggest?
Yeah, so Professor Merrick, we also have a brief presentation about our future plans and stuff. So as I mentioned, we can take a last question from moderated by you, but then as per your convenience, you can log off, and our colleagues are still here. We can spend another 15, 20 or half an hour to discuss some of these questions and answer them live as well.
Right. One question that is coming from the audience is about project certifications. How can we best impart the results of research and development into construction practice that we will be able to certify that a project, not just a building, not just a final product of the project, but the project itself? How can we certify the whole process, the whole gamut of processes related to a project for them to be sustainable? Is there any effort in India or anywhere else that you know aimed at that effort, at project certification?
This is towards sustainability?
Yes.
No, I mean, in terms of a lot of times what we have is certification for I mean, we have the, what do you say, the LEED and the GRIHA and all of those ratings, which are towards a particular building. And I think as we go into the project level, I think we are getting to a stage where, I mean, where we are looking at construction processes, the design processes, but I don't think those standards or those practices are out yet. Each group tends to use its own approach for that, but that's the best of what I mean, what I can recollect on this. If any of the others want to add to it, please.
Yeah, no, I think you're right, Koshi. I think the standards, the ratings, the certifications that we have are more product certifications. So here's a building, and therefore, is it a green building? Is it not? What level of greenness? But as a project, which combines the product with the process, we don't have a combined certification. Of course, you talked a little bit about the lean maturity kind of modeling, which is maybe step one in a process certification. But you know, whoever asked that question has absolutely hit the nail on the head. We do not have this kind of certification, not only in India. I'm not aware of its existence anywhere in the world holistically. And therefore, it's probably, it's a good question. It's probably something that academics like us should focus on developing, you know, as we go forward.
Okay. Thank you, Ashwin. One last issue I want to leave you with, and then I'm going to log off, is the topic of affordability of green building projects. How do we ensure that green building, and when I say building, it's green construction projects in general, how do we ensure that they are indeed affordable to developers, so project owners, as opposed to a conventional project, conventional construction. There is a broadly adopted myth, at least in the United States, that the green building projects are more expensive than, for a variety of reasons, than conventional construction projects. And however we define green, we've done some research at the University of Maryland recently that shows that green construction can be actually even more affordable. Just the construction phase of the project, not so much just the, we don't have to look at the entire life cycle of a facility to prove that it is indeed economically viable in terms of energy usage, in terms of efficiency of operation of the facility, but the construction process itself. And it has a lot to do with design construction integration. How the design process proceeds, how the specifications for the projects are developed, where the materials are sourced from. All of that actually makes a tremendous impact on affordability. So perhaps looking at affordability of sustainable construction in India is another challenge that could be tackled by future research efforts. So I don't expect an answer from anyone on that, but I just want to leave you with that thought, because this is very important for developers in every aspect of construction. I'm sure there is plenty of brain power in academic institutions such as IIT Madras and in others, and collective wisdom of the industry, how to make it happen. But to compile it into doable practices is perhaps a challenge, and this could be tackled by future research. So I want to thank you all. I'm going to log off at this point and let you continue as you see fit. And thank you very much for your participation, and thank you for inviting me to this very, very interesting webinar.
Thank you, Marek.
Thanks, Marek. Thanks a lot. I think we wanted to answer that question also, but we're going to let you go. Or we wanted to give our views on that too, especially in the Indian context, but we'll let you go. And when we catch up again, we will discuss that, because I think that's a very interesting topic.
Okay, thank you.
But we wanted to take a screenshot. Do you want to just take one? Yeah. Okay. I think the coordinator wanted to take a screenshot of there's Nikhil. Okay. Aslam is not there. Okay. Shiva?
Well, I think Marek left. So
yeah. Oh, okay. Yeah. So let's continue on the other questions.
I think there's only one. Okay, there's a few more. Shall we go through the final slides and then?
Yeah. So everyone, please still keep on posting. I think we have been quite productive. We have answered 114 questions.
Okay.
Yeah.
So
I just wanted to take a couple of minutes to inform people about the kind of plans that we have going forward. I think many of these are, of course, set to answer several of the key questions that Professor Marek had raised. So we have a plan to have a TLC2 Experience Center. The idea of this Experience Center is to look at how we can develop strategies to implement state-of-the-art research that we are currently involved in pilot scale applications. We also want to look at evaluation of alternative materials and processes, strategies through physical and virtual test beds that we'll be establishing in this Experience Center. One of the major objectives of this TLC2 Experience Center would be to train human resources to essentially propagate the kind of things that we are trying to work on in our research. And of course, this will also involve engaging with industry through consulting services on several sustainability related aspects, including policy, auditing, contracts management, and of course, all the other research that we are already currently doing with respect to materials and processes. And the other idea is to bring out new products and methods into the industry. Engagement with startups is going to be one big activity in this experience center. And we hope that all those who have interesting ideas in this domain will come forward to integrate and work with us. And one of our major aspects is to obviously get ourselves involved in solving several of the issues that have been identified as part of sustainable development goals. And we are looking at various different activities that directly impact several of the key SDGs, as you can see on this slide. Next, please. The location, the physical location of the center will be at our Discovery campus in Tayur. The land has been allocated. You can see the building there, but of course, it's not a real building. We are hoping that some of you who are interested will come forward and help us in getting this dream to a reality. We are looking for industry partners to help in raising the required capital to build this facility. This facility will have several important features, as you can see in the next slide. What we want to do is have a workshop space that looks at processing equipment for aggregate. That is obviously one of the key areas that we're looking at. We are also looking at industrial agricultural waste processing and cement production related equipment that can help engage even the cement industry and other manufacturers who are doing alternative materials manufacture for concrete applications. 3D printing is again one major aspect that we'll take a look at in terms of different types of printers which will be housed in the facility to try out various different ideas with 3D printing. And we'll also have a facility for large-scale testing, not just 3D printed wall panels, but also looking at precast segments and tunnel linings, and also develop facilities on structural health monitoring. We also intend to have a pilot plant for solar-enabled thermal treatment for recycled concrete aggregate. This is something that was developed at a smaller scale in research in our group in the last couple of years. We want to take this to the next level and try and propagate this idea to the construction industry. Additionally, building will also have space to train people and also house sophisticated instruments and also mechanical properties and durability lab, along with labs to look at lean construction aspects like BIM and LCA, and also a virtual reality experience lab that can help us visualize several of these processes that lead to much better strategies for construction process. Next, please. So again, I think Nikhil can thank everybody on our behalf, but what you have there is the website address. You can definitely look at the activities and all the videos and other project related aspects that have come out of our group at this website. We urge you to connect with us if you want to work together on some interesting ideas related to sustainable construction in the realm of what we've just talked about. Thank you. Nikhil?
Yeah, thank you, Mr. Manu. Over the chat, I was seeing a lot of excitement by the young engineers from different, not necessarily only civil engineers, but data scientists, mechanical engineers are getting excited about this. And even we encourage so. We would love to meet some of you perhaps through this link that has been sent to us. Send us your queries, the kind of ideas that you have. And we always have opportunities to engage with students through projects, through internships. So that is definitely a channel that we can explore. You can perhaps visit us, see what kind of work we are doing and see where you can contribute. In fact, you would be surprised that some of the leading startups in the area are not necessarily by civil engineers, but mechanical engineers and data scientists graduated from IIT Madras and other universities. So yeah, these days the knowledge is becoming interdisciplinary and we also stick to those principles. So please reach out to us. There are a lot of common questions related to certification of this particular event participation. I think Code G office has already given you queries on that. But I would like to take this opportunity to also introduce some of the things that we are already doing and also planning in the future. One is there is a e-certificate program that at IIT Madras we have launched called Construction Technology and Management. And I think the link of this, I can put it in the chat perhaps, but the first batch of it is already ongoing. And the second batch of this certification program is going to come soon. We have a tremendous response from about 150 people who are actively participating in this certification program. And round 2 of this, we are going to launch soon. And perhaps based on your feedback, then we can have more specific courses. So this is for people to skill themselves in the topic that we have discussed today. So please check that website, and if you are interested for further questions, please reach out to us. At the same time, I would also like to introduce some of the further activities that we are doing. But one of the significant one is the TLC2 week that we organize. We have been organizing annually for past 2 years, and this 2024 is going to be the third TLC2 week, where you are going to have an opportunity to meet the leading researchers from all around the world on this topic, as well as meet some of the pioneers of the industry within India. And this will be held at a physical location in IIT Madras. So we welcome you. We look forward to seeing a lot of you. We will circulate the details to those also, or those who have registered for this event as well. And further, we definitely want to keep the momentum going on. There is a conference on CONSEC, which is the construction in severe environment, which is very more durability related discussion. Again, a reputed world conference on the topic, which IIT Madras is going to host in 2024. So there are a lot of engagement opportunities, whether you are an industry partner, whether you are a student, whether you are an academician, and we look forward to hearing more from you. At this stage, I do not see any much bigger question. I think we have answered all of them. If you still have further questions, visit us our website. There are contact details of each of us, and we'll be happy to take it forward as well. And thank you so much. 270 people are still online. So I hope the content was good, informative, and we look forward to you engaging with you in future opportunities as well.
Yeah, thank you, everyone.
Thank you all.
Yeah, thank you all.
Thank you, TLC2 team. And thanks to all the participants, everyone asking questions about your certificates and the upcoming webinars. I'm dropping in our social media handles in the chat box. Please do follow us on Twitter, LinkedIn, whichever your preferred platform. And we will also be sending out emails to everyone that has registered for this session about the next and upcoming sessions. Thank you, everyone, and wish you a good night. Thank you. Thank you for joining.
Thank you, Zania. Good night.
Thank you.
Close. Good. Isn't that?
Yeah.
Yes.